Are you gonna give me a signal when we go live, or? Cool. Well, welcome everyone here in Stockholm at home on the stream to the Building Your First AI project. So this is actually part two of a series. So part one was kind of starting your AI builder's journey, where we're kind of talking about really about why would we build with AI and kind of answering the questions of what is possible with AI. And this is going to be kind of a next step of once we've decided the types of problems that we want to solve with AI, how we actually do that. So I have a few learning goals that were very similar, the exact same as last time, which was one to kind of navigate the world of AI tools that's out there. So the last session, I had a huge slide of all of the different tools that are out there, and even some of the Microsoft tools. And there's tons. It's a very tooling type of environment now because some of the models that we've built and used and we know are really well, we can build tools on top of them and allow that access to almost anyone, whether they're developers, non-developers. So there's tons of tools out there, but like, how do we choose which ones? So hopefully after this talk, you can sort of navigate that a bit better. I also said that we can hopefully fall in love with what's possible with AI. That is a big ask, I know, to fall in love, but I think it's very possible to do that. And what's great about AI is there's so many different use cases you can use it on. And then, yeah, the other two was really kind of getting a better understanding of the benefits of the AI and applying it to the use cases, and then really just inspiring you to understand what's next. Like, what would you like to do? So I had some sort of stories and use cases of people that not necessarily PhDs or data scientists or professional developers, but they were able to build something with AI, which is really really cool, and especially the best time to do it now. So if I want to sum up like kind of what the whole theme of this is, so the last talk was kind of like why would we use AI and how that's sort of possible. This is going to be talking about like how can we actually use it, and then as like a third part would be okay. Finally, we've answered those questions. Like let's do it. Let's use AI, and we can go straight into the code. But I think what I've seen in many other kind of presentations is we get super excited about like okay, we can solve this, and then we go straight into showing you code examples and stuff like that, but not really explaining why we're starting doing that or like why the code is doing what it's doing. So this is going to be sort of a step back to that and answer the question of like how can we use it and why we sort of doing the things that we do. A little bit about myself. So I'm a cloud advocate here in Stockholm. I specialize in the AI space. So I do workshops such as this and doing talks on really trying to inspire people to build with AI. I think it's an incredible technology, and it's something that I think affects almost everyone here. Like everyone's, I like to say, is a data point in someone's data set somewhere. So it's good to get some understanding of fluency around what's possible with AI. So I've helped some different AI startups and builders around to understand what is possible and apply this to use cases. I'm also the organizer of a machine learning club here in Stockholm, which we kind of really focus on expanding education here, and as well as what it's actually going to be building there. And then lastly, I'm very proud to be an ex-podcaster. So lots of people brag that they're a podcaster before and that they've done that. But I used to have a podcast called The Maker Show, which we were interviewing people who were building with AI and how they got their start. So actually, the steps to building an AI project that I think only maybe one person or two people in the audience were here for the first talk. So I was going to quiz everyone to ask like if you remember, because I gave you a sneak preview of what the first step is, but I won't put any pressure on those two people here today. But really, what I said was the number one step or step one to AI success is framing the problem, like how AI can actually solve that. And what I always said, that even though I'm a huge advocate of AI and a lover of what it's possible, I always say like, can this actually be solved in another way? Because sometimes things that we want AI to do can it be just automation, right? If we want to take an answer of something and look it up in a database, or maybe we want to automate some sort of process, it's not necessarily that we need to build an AI model or machine learning model to do that. And I think it's important to sort of question that before you get started, so that you can specifically know what AI is going to be solving in this problem, and what it's not going to do. And then also looking at predictions. So what we work with AI is all about predictions. And then we use those predictions to either sort of drive some sort of process, like, okay, we take the prediction and then we're going to move this email somewhere, or maybe AI is moving the email itself, kind of thing. So it's, it's built into an automated process, or maybe there's a person kind of manually doing this, looking at the predictions. And it's super important to kind of know where AI sits in that process, so that you can kind of know really what you're comfortable with AI doing. And then, like, what will the world look like after? So how much improvement do we expect? Whether it's in some businesses or enterprises, like a 0.1% increase in efficiency is $1 billion in revenue or something. But maybe for you or your use case, it's not that important. That, like, it needs to be like 50% accurate, 90% accurate, or something like that. So it's important to know how much improvement we're trying to do as an end goal. So these are like the 12 steps of building an AI project. And to be honest with you, I could probably do a talk on each of these individually. So this is going to be kind of summarizing everything there. And maybe in the future we will talk about each of them and drill them down a little bit. But if you do have any questions in the stream or in the audience about them specifically, feel free to ask whenever. Um, and this will be sort of a kind of navigating the different tools that are out there. So if you do have a laptop, feel free to, I will take some time so you can kind of navigate the websites, because I know it's kind of annoying to throw different things out at you, and then like you have to like try to save it on your phone or whatnot. And if you're at home, of course, put me in a new tab and just start looking at those pages. It's cool. But the first thing we'll talk about is getting the data. And that's super important, because that's the driver of everything that we do with AI, is building a data set. And there's one way you can sort of do it, is if you want to kind of go the hard way, if you will, is actually creating your own data set. So there's a few different ways to do that. There's ways you can scrape a website. So for instance, we have Beautiful Soup, which is the Python library that's highly recommended, and a lot of the beginner tutorials will have that. But lately, I've been a big fan of Scrappy, which is also a web scraping library. And it's, I think, maybe a bit more to set up for a beginner side of things. But I think it's way more flexible, because one of the tricky things with web scraping is you sort of have to understand the structure of a website, and this allows it to get a lot more dynamic data. And it's important because when you're scraping websites, they all have different ways of displaying the data, or where they hide things in search results. So getting a good web scraper that can kind of handle that dynamic data is super important and makes your life a lot easier. Also with images, so again, when we want to do some things with computer vision, it's really important to pull and have an image data set. So there's a Google Image Downloader, which is both a Python library and a Chrome extension. So if you're not a big user of Python or don't have those skills yet, you can use this as well. And then OpenCV, which stands for Open Computer Vision, is another Python library, but it also has some embedding where you can quickly build an image and video data set. So those are kind of ways if you want to create your own. But I always recommend, especially if you're starting out and this is your first kind of adventure into AI, is to find free data sets. So there's tons of free data sets online. I know of one of my favorite searches, even though this is a Google product, is this data set search. So you can search just about anything. So I'm a big football fan, and find, like, okay, here's all of the Danish football fixtures, and maybe the results of them, and you won't want to like build a data set on predicting these results, for example. What's tricky about this is these aren't necessarily always in a good format to work with AI on. So you might have to scrape the websites, but most of these websites that are hosted here, or you could find, are in like a very clean way, so that you can easily scrape them if needed, or if allowed to as well, for policies wise. But I think the king or queen of finding data sets is definitely Kaggle. So if you've never experienced that, it is, what I think is so great about it is, one, it has the search built in. So if, again, I want to search for Football data sets. Let's see. So I can say there's like football events, football results from 1872 to 2022. So that's quite a long time, basically. And yeah, you can find like the different formats of the data. And what's also quite nice, I didn't show you here, but you can kind of filter out on what file types you have. Like CSV and JSON are probably the easiest file types to start working with. And so this one already has the results in there, and I can see here, there's the home, the away team. So Kaggle, I think this would be your best place to start looking for data sets. And again, one of the things, it might not have like a perfect data set for you. Like this has, the home, the tournament, city. Maybe you want to like look at who scored or something like that for this model that you want to build. So this is probably a good start, and you can always see like combine data sets to build, mega data sets that are really tailored to what you're trying to solve. And then with Azure, we have actually some open data sets that can kind of easily be embedded into some of your projects on the Azure cloud. So we have like some transportation, COVID, which is quite relevant, obviously, and even some US labor statistics and stuff like that. So again, free data sets are out there. They're quite clean and really easy to sort of embed into your project. So I would always recommend starting with that. And then if you want, you can sort of look at it later on to build something else. Specifically for the Swedish audience here, Sweden is a great country with great open data. So we actually have a data portal, .se or .se on this side, and this is in English, so for anyone else. And you can easily find data sets here. So if I go to like search data and APIs, like I can see that there's, the school meals in the city of Lund. I'm not sure what you would do with that with AI, but there's tons of this types of data that you can easily find, and and they even show you the format of that. So especially if you're working with city data or you want to try to solve some sort of problem that cities face, you don't necessarily need to have like that city for that data set, but maybe somewhere that's a similar city or something like that, you could start to build or sort of build a proof of concept on your data. So Sweden, and I think most big cities are sort of embracing that. I know New York City, for example, has another open data portal. So worth looking at when you're looking for data sets, especially in that area. And there's a few other ones. There's like a subreddit for data sets, so you can like openly request data sets, and some people will recommend ones that they've used, which I would recommend you doing as well. But once you actually get the data, it's really important now that you sort of clean and format the data. And why is that the case? Well, one, you might have a lot of unwanted data points. So, some data, even on Kaggle and these sites, might have duplication. So there might just be a double of entries for however they collected it, or maybe they collected from multiple sources and they use that. So it's important that you probably want to remove that, because then the model might weigh this or understand this data more, because there's so many of these. So it can get kind of crazy sometimes. You can have like 360 examples of one data point, and you would definitely want to remove that. Then you also want to remove errors, so like inconsistent labels. Most data that you work with is either collected by a machine or collected by a human. And as we all know, humans make mistakes sometimes, and they get lazy when they are doing data entry. So, for instance, an inconsistent label could be something like Stockholm with a capital S, Stockholm with the lowercase s, maybe Stockholm, comma se as like the city name, and you have all of these in your data set. And if you give the model that, it's going to think these three things are completely different, when in actuality they're the same. So you want to understand and look at your data to understand if there's any data and also missing data. So sometimes people add different data points, and then there's like gaps and openings there where there's not actually data that they could have collected, or they did collect and just forgot to record it. So it's really important to look at missing data, because it's also something that will skew your model to decide what the world looks like in the wrong way. And then the classic sort of statistical stuff, like you want to standardize your data. You want to make sure like there's no outliers, especially when there's things like salary data, for example. If you want to take for a city and you take one zip code and another zip code, maybe this zip code like has a lot of dentists and doctors and lawyers, like high salary, and then this zip code doesn't. you want to make sure that these is sort of standardized across the board. So the one way you can do that is working with a library in Python called Pandas, which makes this a lot easier to do. I mean, you can go into your Excel document and try to find it, but I wouldn't recommend it because that's going to take a lot of time. So we have a module here where you can plan a moon mission using Python pandas. I haven't personally done this one, I'll be honest, but it sounds very interesting, and it's also got a lot of what you need for both using things called data frames, which is kind of how pandas handles data, and then also then when you're actually getting the data and collecting it, how do you sort of clean that? So it does it in a fun way. I think this is based on like a Netflix series or something like that. So yeah, it's a good place to start with pandas. And I think what's really great about pandas too is there's a lot of Stack Overflow pages about it because it's easy to forget some of like the methods and ways that it handles the data, and people are constantly asking about it. So whenever I get stuck, that's what I do with for pandas. Okay, so then we've got the data, we've cleaned it. Now it's actually like important to kind of explore and understand what is in the data and split the data because that's another thing that's important for training the model. And why we sort of explore the data, like I said, is kind of understand the different gaps that you might have in data that don't relate to the real world, or maybe you're trying to solve the problem. So, for instance, you can, if you want to do some prediction on, let's say, robot mechanics, and you have all the robots that are in one country and it's like a really cold country, but you want to predict these like robot maintenance worldwide. um, if you can look at that and you have a data set that has like temperature or location, you can understand that, okay, maybe I need to now explore or get different data points from different locations, because it's important that it reflects the problem that you're trying to solve. You can also eliminate things like bias. So one of the things I think AI gets a bad rep for is because if you look at different press and releases and things like that, what happens when we launch an AI model and it like can't predict people of a certain skin color's faces because no one actually took the time to like look in the data set and realize that they didn't have those samples. So it's super important to then look at how your data is representative to what it's going to be actually used for the user side of things. And again, it's using things like pandas. We also have two other libraries, NumPy and Matplotlib. NumPy does some of the more mathematical things like mean distribution, and Matplotlib does more of the visualizations. And visualizations is great because then that gives you, as a builder of with AI, a better quick snapshot of that, where you wouldn't get if you just looked at each data row or the numbers per se. And then we also want to achieve generalization of working with data. And what that means is essentially you don't want the data to learn or like be memorizing your data set. So you want to split the data in different ways so that when you're training the data, which we'll talk about later and what that means, it can then be generalized as far as understanding the problem you're trying to solve. And then later on can be used for new different data points and data things when you have the model in production or being used by users. So you want to have it generalized to be able to solve the problem. And the way we do that is we sort of split the data set. We'll go in more detail what the data splits mean, but we do it from training, test, and validation. And normally it's like a 80-20 type of rule, but depending on how big your data set is and how deep your problem is, it's important you might want to adjust those things. But next was like now we've gotten like the data and we've super happy with what we want to decide. We want to like actually pick the tools that we want to use. And I said right tools, or right problem, right tool, right results. And I didn't say that just because like it's cool to say right three times over or it sounds nice. I think it's super important because one, when you have the right problem, like we talked about last time and a little bit today, is then it's really about, okay, how do we look at the different problems AI can solve and which tools we want, and that makes our lives much easier for predicting the right results. And I think once you start working with AI, things get really messy. Like you have different, you get different data. You go to Kaggle and you start looking and you start pulling different files down, and then maybe you make some edits to one data set. If you get to do another one, so you want to make sure that you have like a good managed environment to do all of this work in, and it's also going to save time and resources. So before, I got a question about like, what if I have a bad laptop? Like, what should I do? Because I know this is going to take a lot of memory. So again, depending on the problem that you're trying to solve, yeah, maybe your laptop isn't sufficient enough. So we do have, as far as like Azure, you can use different cloud services where basically you're loaning a machine for the time being to train your model. So that's another way. Again, you're kind of saving time where you're not like train the model and like go home and then your computer or laptop's like going to catch on fire because it's overrunning. So those are things that you need to consider when you're picking the right tools. So for I think the standard for most people, I think, is like using VS Code and then a thing called Jupyter Notebooks. So if you haven't ever seen anything like that, basically a Jupyter Notebook is, let's see if they have one here, um, like a kind of controlled sort of web app where you can, it's not a web app, but you can kind of operate using your code within this page. So it makes it super simple. Let's see if I could find one to show you. I can make one. So it's something like this. You can kind of change the different versions of Python, which it gets a little bit tricky, and you can make really easier runnable code with that, and also share it. So it's like easier for people if you want, like doing a workshop here, or if you're working with other people, you can create a Jupyter notebook in VS Code and then share that with the results there. And it more or less pulls the same dependencies that you use with different libraries. So you don't have to worry about, oh, it's working on my machine, but it's not working on yours, which is kind of the classic developer issue of the time. So that's something to look at. We have this one I pulled up here, which is getting started with Jupyter Notebooks for Python. So I highly recommend that because it also shows you how to work with VS Code. So if you've done some development before, you can easily work with that within VS Code. And then the library of choice for me is PyTorch. So it's an open source library. There's another one out there called TensorFlow. And if you Google PyTorch versus TensorFlow, you'll probably get a million results of people debating which one is better. And you can choose which one. It doesn't really matter. I think it's a natural thing that whatever you learn first is like the one that you think is the best, and you will fight to the death until you're proven wrong. So it doesn't really matter. Again, my preference is PyTorch, and it's really nice. Also, we have this like um, fundamentals course, which is actually, if you look, so we have the fundamental course of Microsoft Learn, which is nice, but it actually attaches to the tutorial that's on PyTorch itself. So we've collaborated or contributed from Microsoft perspective on tutorials for this library. So it's a great community, and honestly, I think that's where you probably want to place your bet whenever you're picking tools, is like how many people can help me later on, and PyTorch is like a great community for that. And then lastly, the big one is Azure Machine Learning. Again, that is how we use the cloud technologies to train our models. So we have a few different options. So we're creating a model, and look at that. There's our friend Jupyter Notebook again, and so we can actually work within Jupyter Notebooks to do that. And then we have things like AutoML, which is we're going to talk about like choosing a model and the model metrics and stuff, but maybe you're like not interested in all that, which is completely okay. Um, AutoML allows us to train models and then essentially automatically chooses the best model based on that. So it's again another way to kind of get up and running quickly. And and then we also have Azure ML Designer. So it's like a visual tool. You can kind of see it here, but you can take the data, you can do some data cleaning on it. You can normalize the data and train the model visually, kind of drag and drop. But again, all of the steps that we're talking about here still need to be done, which is important, but you don't have to do that with code. So those are kind of the three options on the cloud side to kind of again save your laptop from running into the ground, I guess. And it really allows when you're building some complex models, especially around the computer vision and stuff like that. It allows you to work on that pretty quickly. I've like lost my mouse. Let's see if my finger can work on it. There we go. So we picked the right tools. Now it's actually like time to train the model. And this is the process of like actually the model learning from your training data set. And like cliche as it sounds, like this is where the magic happens. And I put magic in quotes because a lot of people, once if they come from like a statistical background or a math background, most of the machine learning is like classic statistics with large amounts of data. So it's like not nothing too groundbreaking in most models. Some of the neural networks and deep learning definitely is. But it's really training a model and a model to get understanding of where you're doing with the training data and essentially curve fit, essentially finding ways and patterns within the data so that when a new point comes in, it knows where to place it. So it does this by doing like feature extraction when we're doing deep learning and is understanding exactly what makes the data itself and also how to make correct predictions. So how it actually does that is first we feed the model the training data in what we call epochs or epochs, depending on you ask. That's how you say it. Basically, an epoch is like when you take all of the different data points that you have in your training data and feed it into your model to learn at least once, and it goes over and does that again and again to make sort of correct predictions. So the model makes a prediction and then kind of makes an adjustment in different weights and how it sort of calculates the predictions to see if that new adjustment is a correct prediction in most cases. So this is also when we're training, we can actually calculate how well the model is performing. So after every step or after every epoch, we can see the performance evaluations and understand, okay, maybe this is not going well, and we can stop the training. So we have some different tips and techniques around that. But then ultimately, we want to get a model that's trained on the data that can again generalize, but not overfit or memorize the data there. So once we can have a nice model to train deep learning models, which I think is again the most interesting and most dynamic from at least my opinion, or from the machine learning and AI side of things. So what's really cool is that we'll use PyTorch or TensorFlow. So again, if you sit on the other side of the TensorFlow side, it's cool. And then you can also use things like transfer learning, which is to train pre-trained models, but kind of adjusting it to our data for that for the specific use case that we have. So every time I zoom in, I like lose my mouse. I might stop zooming in. I don't know. So lastly is like analyzing the results. So once we've done some training, what is that, and like what do we decide on how well the model has performed? So first, one, we need to understand if the model has trained well, and then also we can understand how or what we can do to create ways to improve the results. So how we do that, I think when we go around using some of these libraries, there's two key metrics that we primarily look at, and that is loss and accuracy. So loss is like a penalty for wrong prediction. So as the model trains and as it makes predictions, there's a formula loss function, as we call it, and there's different loss functions for different problem types. It calculates, okay, this is basically a distance from the right prediction. And obviously, if you are making a penalty, you want loss to be decreased. You don't want less penalties. And accuracy, as the name sounds, is basically how accurate the model is as predicting it. So we take the number of correct predictions and the total number of predictions, we divide that, and that gives us the accuracy. So in that case, we want the accuracy to go up. So we want it to be, at least one is the perfect model. So we want at least a good accuracy there. So if we look at, I'll show you one kind of quick code example to show you what that looks like. So if putting all of this together, so first we're going to set some values. So these are just the variables of the loss. So the training and test, like I said, we do some splitting of the data. We have an epoch. So every time we run an epoch, we just like increase the count of the epoch. We'll take some steps as far as like, again, the training, the model, how it learns. And then we have different loss functions that we will assign itself to. And then we also set these variables to 0 so that once we evaluate the model, we can get those numbers, the loss and accuracy in these variables, and so we can track on them. So let me show you what the output looks like. So again, we're doing these training steps, the model, and then we have epoch 1 out of 5. So we set this to 5 epochs, and we can see the training loss, the test loss, and the training accuracy. And in a perfect world, these numbers would continue to go up at times, but you don't want to go up. You don't want to train too much, because then if the model understands or overfits the data, you might have like 100% train or zero, 100% accuracy on the testing. But then when you bring the model out into the real world, it doesn't perform well because you've just overtrained the model in there. So you want some sort of balance. And I'll kind of I think these are really great tools and things like that to give you some understanding of where what that looks like and how you can kind of outweigh those things. So after Van, yeah, mm, yeah, exactly, yeah. So yeah, to that point, right? Great segue. I don't know if you saw the slides already. Is the testing and model validation side. So why we do this, right? It's I've been kind of saying is that we want to make sure that the model we understand how the model will perform in the real world when we deploy it. Also, we want to use, especially on the validation side, which model to choose. So this is like an iterative process when you're building and training a model. So you never like don't get it right the first time. So you want to pick different models, set different hyperparameters and variables, and see how those will perform. And that's what we use for the validation set. And then also we look at data sets that haven't been seen before. So the test and validation side of things, and we need to know then like since the model has performed well in the test, how well it will perform in new data, and we can do that in a sort of closed environment without having it, released to the public and having it perform well. So how we do that? So to your question, so the first is the validation side data set. So this is literally only used for valid evaluation of the model, so it's not used for the training. So it's not like the chunk of data, the 80% or 70 that you might use. And we feed that to the model and see how well those predictions are. So we want the accuracy on these hopefully to be greater than the training data in a way so that you can that's a really great result because then we can see that the model once it's deployed or at least validated that this is going to be giving some good results and it's not fixed to the training data set that we used. And then we also have the test data set. So once we've validated this is the model that we want to use based on all of the different models that we trained, we want to say, okay, great. One last time, this is a completely new data set. How does this perform on this test data set? So I like to say it should reflect real world scenarios and also should kind of have the same distribution or the amount of categories and things like that in the training data set that you use. And we want the accuracy, if it's less than the training data, then we know that we've sort of overfit the training data and it's not a generalized model and won't necessarily perform as well as we had hoped it did when we were doing the training. And then lastly, I think the most important part of all of this is that like, we've done all these like 11 steps of training and choosing finding the data is like actually getting it out there and deploying it. So it's kind of rewarding all your hard work, also solving the problem that you're trying to solve. And models don't exist in themselves to be valuable, but in themselves to be valuable when you apply it to a problem. So and you want to probably integrate this with some sort of application or user interface or something. So with the machine learning studio as well, you can easily deploy this as a service. So I can show you what that looks like. So you can make it like an API endpoint. You can test these things out. You can give it some inputs, which is like kind of what you probably used for the training, and it can give you the result, and you can display that to the user. So again, that is where you want to end up at the end of the day, is to be able to confidently deploy this into some sort of application. And this is not a one and done sort of thing, where even after you deploy the model, you can actually start back at one, and maybe you need to frame the problem again, maybe you need to get more data, but it's all about first kind of getting it out there. So, like I said, framing the problem is probably again the number one place to start, and then you want to end in deployment, but you might, as any sort of data science or AI or ML experiment, this is sort of a cycle. Uh, I can't really make this a cycle in this kind of graph here, but that's really where you start and end up. It's like you might need to get new data, you might need to clean it better. You might want to pick different tools that may be better applied to your skill set, but ultimately, getting the model out there is the probably the most important thing to building some sort of production ready and deployed AI model. But yeah, that's basically it as far as the cycle of in building your first AI project. I appreciate everyone listening at home and listening here. If you have any questions, we can go ahead. Yeah. Yeah, that's a great question, and I don't think people on the stream could hear. But so you've asked, maybe you've gone through the training process, and then you realize, like maybe some data in your data set is corrupted, or let's say not relevant anymore. That's a really interesting space and a really interesting question. I don't know what the best answer is, other than you probably will need to retrain the model, largely because you can't, at least at the current, abilities that we have, like pinpoint that the model has taken these corrupted data and considered it in this decision or this prediction. So there's different ways you can kind of there's a different kind of area of study called explainable AI, and you can get different models and graphs where it can show you how the model basically came to a decision, but it won't. So you can kind of see maybe the corrupted data has affected this decision in a way, and you can throw out that prediction. That's one way, maybe. But to be honest, again, obviously depending on how much corrupted data, you might want to retrain your model. Great question, though. Yeah, and that's kind of where framing the problem and knowing how comfortable you are with, let's not say wrong predictions, but less right predictions, is because then you can make those decisions, and okay, maybe in this process of where the model is, it's not automatically automating a decision. So yeah, you get the wrong prediction based on this area or where the corrupted data lies. You can just choose not to use that prediction, for instance. But you still need to probably use some of these explainable AI frameworks to really know where the AI or the models making the decision. It'd be really hard to do that without it, I think. Sure. Yeah, stop there. Stop there. We don't need any more. Great question. So there's a whole area of, I guess, study or work called ML ops, and it's kind of answering that question, like how can we do that in an efficient way? And there's like a famous article on that space called "ML ops is a mess." So it kind of tells you how far along we've gotten with that. But yeah, that is a good question, because when you collect data on a data set, there could be, like, you might collect new data points, but it might not actually affect the way the model makes these predictions. So it's a science, or of deciding when you want to retrain the model, how much more data that you've collected and in what way. So again, you really need to kind of keep a tuned eye on your current data set, where the gaps are, which you can using some of the tools that we explained. And then when you get these new data sets, new data points, basically maybe you're getting it from users or you found a new data set, when you decide to retrain. If you're doing smaller models, retraining is not that costly in certain cases. So, yeah, maybe retrain after you get 5 new data points, 10 new data points. But it's up to you on, how much cost you're willing to bear on retraining the model, from both a cost perspective financially and time and things like that. So maybe, retraining the model doesn't make sense to do it when you get, one new data point, but maybe it does when you get 1,000 new. So always to consider, like, what proportion did you have in your original data set. So maybe you have 1,000 data points in one, and then you get a new, 500 new data points, and it's probably a great reason to retrain. But again, it's like it's not a hard and fast rule, so it's really up to you on your project. Mhm. Yeah, yeah. No, there's quite a lot of different ways to monitor that. So like that's another whole nother tools of like when you want to like there's things like hot swapping your model. So you can like let's say you have the deployed model and to your question because people can hear it at home, but like yeah, you might have a deployed model that's stable and you don't want to swap it out or you want to keep that using but then retrain. So you can have a model in production and also a model that's training. And then there's different tools out there that you can hot swap them, see the performance, swap them back in and out, and it's all taken from well, in theory from the DevOps environment where you're also doing this type of work, but using it now for machine learning models and different tools there. So yeah, it's a very exciting space. So highly recommend you looking at it, and maybe we'll do a workshop on it. Hmm. Yeah, no, and to the question, so you asked or said at least about uh yeah, like normally you have a domain level knowledge or you hopefully you have someone that's doing both. And I think I don't know, maybe I'll be wrong in saying this, but I think a lot of times you have like the infrastructure team or the people that are very well at setting up the company's infrastructure, and they're actually just now understanding what it requires to put in a model in production, the different tools that will require from a company perspective, and so it's kind of like now finding a way to marry those two different levels of expertise, which is AI data scientists, like even like a Jupyter notebook hosting that internally. Where do we host the data set? Like, do we need to keep that in house? Can we host it in the cloud? All of these questions, I think, are consistently getting answered by most companies and stuff like that. So it's a interesting space. Yeah. Yeah. Oof. I mean, I haven't seen anything that like I have seen some things I guess that yeah can kind of give you an idea of where your bias is. I haven't used any of myself, so I can't say like, "Oh, use these tools; these are the best ones." To be honest, I think some of the stuff I recommended, so the Python libraries of just understanding your data analysis as well as where your data is skewing, I think is important because even if you have a tool that says something is has some implicit bias, that tool might also have bias in itself. And so I think also it's nice to, as a practitioner or a builder of AI, make those decisions yourself because bias not necessarily is wrong. It just in certain use cases it can be harmful. But it maybe in certain ways you do want to have this bias because that's where your use case is being defined at. So yeah, I think I can't recommend specific tools for you, but I'm sure there's great ones out there. Yeah, that's a great question that I think the world of AI ethics is constantly asking. For me, I think I mean the best approach is to understand where you're. Like, if I was a data scientist working in an organization, is understanding as your stakeholders or how this AI is going to be applied. So, for example, AI in HR or recruiting is quite a hot area for understanding bias because well, I mean, as humans, we have bias for deciding which candidates get hired. That's just like a natural thing. But like, how much can we accept in this process, and if it's a good thing, or are we mimicking the biases that are harmful in our society or our way we make decisions now? Are we mimicking that in the model? And if so, we're probably doing that at scale, which is quite different to what we would do as like one person with one CV reviewing it. Now we have a model that can review, you know, thousands of CVs in a second. So I think it's always going to be understanding your stakeholders, having that discussion on how they make decisions, and making sure, looking at your data, and making sure those, if there are harmful decisions or ruling people out, that those aren't replicated in your data in a way. So you might have to do, you know, it's kind of tough, but you might have to rebuild your data data set in a way that doesn't reflect that, or building some sort of mechanisms within the end product to the user to account for those biases, I think, are probably the easiest, or not easiest at all, because none of this is easy, but probably the most efficient way to do it. Yeah. Yeah, but yeah, yeah. Well, I mean, to this question, I think they're asking about the latter bias, where it's the data and how, like, I guess, kind of not. I mean, ethically, we decide on what's in the data set, and I would hope that you wouldn't necessarily need to backtrack when you make the prediction. I mean, in most cases, you might have to, and you can say, "Oh, the model made this prediction there," and you can backtrack. But ideally, you would want a model or a way to do working where it works better while you're having it in production, I guess, or in the way you're using it, where you don't have to trust that someone's going to make these decisions. And it's interesting where, there is like a very clear black and white legal issues for data, but then there's all these gray areas. Like, for instance, you mentioned school. Like, most people wouldn't realize that's something maybe that is has a bias in this case, an ethical side of things, on deciding which candidates get progressed or rejected. But you need to have those discussions with stakeholders beforehand, and you need to understand what's in your data set to have that knowledge, I think. Yeah, yeah. Yeah. Yeah, I mean, it depends on the model that you're trying to train as well. So there's this approach called, like, I think it's I don't want to get this right, one hot fixing, where you actually use less data, or you don't need to build this whole data set to get actual results. So if you look at some of the NLP stuff, you can actually have these sort of pre-trained models on lots of different parameters and get results quite quickly. Like, you can just ping them, or you can use this models that have already been trained, and if they apply to your use case in a way, and most providers can do that. And I will show you the auto ML, which, again, you still have to do some of the processes of that, but once it's deployed again, you can have those that's set up. All right. Any more questions from the viewers? Great. Cool. Well, if no more questions here, I'm here for people here in Stockholm to chat further. But yeah, thanks.